The world as we know it operates on a set of rules. These rules, governed by classical physics, dictate the motion of planets, the flow of rivers, and the trajectory of a thrown ball. Classical physics, with its laws of motion and gravity, provides a framework that explains much of what we observe in our daily lives. But when we zoom into the subatomic level, a stranger, more counterintuitive set of rules takes over: the rules of quantum physics. This microscopic world operates on principles that often seem to defy our everyday experiences. This realm, where energy exists in discrete packets called quanta, challenges our conventional understanding of how the universe works, and particles behave like waves, often defies common sense. The famous double-slit experiment, for instance, reveals that particles can display characteristics of both particles and waves, depending on how they are observed. Yet, it underpins the workings of our universe, from the smallest atom to the largest star. The principles of quantum mechanics are fundamental to the structure and behavior of everything around us. Our journey into the quantum realm begins with a simple question: what is matter made of? This question has intrigued scientists for centuries and has led to some of the most profound discoveries in physics. Classical physics treats particles like tiny solid spheres, each with a definite position and velocity. But quantum physics paints a more complex and fascinating picture. In the quantum world, particles are not just points in space. They are described by wave functions that encapsulate all possible states they can be in. Here, particles can exist in multiple states at once, a phenomenon known as superposition. This means that until we measure a particle, it can be in a combination of all possible states, and their behavior is governed by probabilities rather than certainties. The outcome of any quantum event is not deterministic but probabilistic, adding an element of randomness to the universe. This inherent randomness, far from being a limitation, opens up a world of possibilities and challenges our very understanding of reality. It forces us to rethink concepts like causality and determinism. The quantum realm is not some distant abstract concept. It is a very real and tangible part of our world, influencing technologies and scientific advancements. It's woven into the fabric of our everyday lives. Many of the devices we use daily, from smartphones to computers, rely on principles of quantum mechanics. From the lasers that read our Blu-rays, which rely on quantum principles to function, to the transistors that power our smartphones, which are designed using quantum mechanical models, we are already reaping the benefits of quantum technologies. These advancements are just the beginning, and as we delve deeper into this strange and wonderful world, we can expect even more revolutionary applications to emerge, transforming fields like medicine, materials science, and artificial intelligence. Quantum computing, for example, promises to revolutionize how we solve complex problems, potentially leading to breakthroughs in drug discovery and materials engineering, transforming fields like medicine, materials science, and artificial intelligence. The future of quantum technology holds immense potential, and our journey into this realm is only just beginning. As we continue to explore and understand the quantum world, we will unlock new possibilities that could change the very fabric of our existence. The birth of quantum physics in the early 20th century marked a profound shift in scientific thought. It challenged the deterministic worldview of classical physics, where everything could be predicted with absolute certainty if we knew the initial conditions. Instead, quantum physics introduced the concept of probability and uncertainty at the most fundamental level. This paradigm shift wasn't easy to accept. Even Albert Einstein, one of the pioneers of quantum theory, famously struggled with its implications, famously declaring, "God does not play dice with the universe." Nevertheless, countless experiments have confirmed the bizarre predictions of quantum mechanics, forcing us to rethink our understanding of the universe and our place within it. The quantum revolution wasn't just about new equations and theories, it was a revolution in thought, a complete overhaul of our intuition about how the world works. It forced us to abandon the classical notion of a clockwork universe, where everything moved with predictable precision, and embrace a universe where chance and randomness played a fundamental role. And yet, within this seemingly chaotic quantum world, a profound order and elegance emerged, revealing the universe to be even more awe-inspiring and mysterious than we could have imagined. One of the most mind-bending concepts in quantum physics is wave-particle duality. This principle is a cornerstone of quantum mechanics and has puzzled scientists for decades. This principle states that particles, like electrons and photons, can exhibit both wave-like and particle-like properties. This means that under certain conditions, particles can behave like waves, spreading out and creating interference patterns, while under other conditions, they can act like discrete particles with well-defined positions. This duality is not an either-or situation, but rather a both and reality. It challenges our classical understanding of physics, where objects are either particles or waves, but not both. Depending on how we observe them, these tiny constituents of matter can act like localized particles or spread out waves. This observation-dependent behavior is a key feature of quantum mechanics and has profound implications for our understanding of the universe. Imagine a beam of light shining through two slits. This simple setup leads to one of the most famous experiments in physics. Classical physics would predict two bright bands on a screen behind the slits, corresponding to the light traveling in straight lines. This is because in classical physics, light is thought to travel in straight lines like particles. However, in the quantum realm, something much stranger occurs. When we perform the double-slit experiment with light, we observe an unexpected result. The light waves interfere with each other, creating a pattern of alternating bright and dark bands, known as an interference pattern. This pattern is characteristic of wave behavior and suggests that light is not just a stream of particles, but also a wave. This experiment, known as the double-slit experiment, demonstrates the wave-like nature of light, even though we often think of light as being made up of particles called photons. The results of this experiment were groundbreaking and led to a deeper understanding of the dual nature of light. But it doesn't stop there. The implications of the double-slit experiment extend beyond light. The double-slit experiment can also be performed with electrons, which we typically think of as particles. When electrons are fired through the slits, we might expect them to behave like tiny bullets, creating two distinct bands on the screen. Astonishingly, electrons too exhibit an interference pattern, proving their wave-like nature. This result was even more surprising because electrons have mass, unlike photons, which are massless. This duality is not limited to light and electrons. It applies to all particles at the quantum level. Protons, neutrons, and even larger molecules have been shown to exhibit wave-particle duality under the right conditions. It is a fundamental property of the quantum world, blurring the lines between waves and particles, and challenging our classical intuitions about the nature of reality. This duality forces us to rethink our understanding of matter and energy, and it continues to be a rich area of research in modern physics. If wave-particle duality has left you scratching your head, prepare for another mind-bending concept: superposition. This principle is one of the cornerstones of quantum mechanics, a field that challenges our classical understanding of the universe. In the quantum world, particles don't exist in definite states until they are measured. This means that the very act of observation plays a crucial role in determining the state of a particle. Instead, they exist in a superposition of all possible states simultaneously. This is akin to having multiple realities coexisting until one is chosen by the act of measurement. Imagine a coin spinning in the air. As it spins, it embodies a state of uncertainty, representing both heads and tails at the same time. Before it lands, it's neither heads nor tails, but rather a blurry combination of both. This is a simple analogy to grasp the complex idea of superposition. This concept is often illustrated with the famous thought experiment known as Schrödinger's cat. Schrödinger's cat is a thought experiment that delves deeper into the perplexing nature of quantum mechanics. In this thought experiment, a cat is placed in a box with a device that has a 50% chance of releasing a deadly poison. The device is triggered by the decay of a radioactive atom, which is a random event. Until the box is opened, the cat is considered to be in a superposition of states, both alive and dead. This duality exists because we have no information about the cat's state until we observe it. Only when we open the box and make an observation does the cat's state collapse into one of the two possibilities. This act of measurement forces the universe to choose a definite state. Superposition doesn't mean the cat is both alive and dead. It means the cat's state is undefined until we make a measurement. This highlights the role of the observer in the quantum realm. This inherent uncertainty is not a flaw in our understanding, but rather a fundamental aspect of the quantum world. It challenges our classical notions of reality and forces us to rethink the nature of existence. It means that at its core, The universe is probabilistic, not deterministic. This probabilistic nature is what makes quantum mechanics so fascinating and at times so baffling. The future is not preordained, but rather a tapestry of possibilities, constantly unfolding and collapsing into reality with each passing moment. Each decision, each observation, shapes the fabric of our universe in ways we're only beginning to understand. Embracing this uncertainty allows us to explore new frontiers in science and technology. It opens the door to innovations that could revolutionize our understanding of the cosmos. From quantum computing to teleportation, the principles of superposition and entanglement are paving the way for breakthroughs that were once the realm of science fiction. As we continue to delve deeper into the quantum world, we must embrace the uncertainty and the endless possibilities it brings. The journey is just beginning, and the potential is limitless.